Okay, Chapter 8, Parametric Equations. Parametric equations is simply an alternative way of naming a function that's given in terms of y and x. If a function is given in terms of y and x, it's called a Cartesian equation. So, for example, y equals sine x, or y equals to 2x plus 3. And instead of giving over a one equation, y equals to something in terms of x, you defined the x in terms of you introduce another variable, t for example, and then y in terms of the same variable. So overall you will have three variables. That extra variable that's being introduced is called a parameter, and just another variable. So it's normally we use t, sometimes letters like m or theta if it's trig equations that are involved. Each point on the curve has a unique value of t, so it changes as you go along the curve, and it will follow the path along the curve. As t increases, you will be traveling along the curve in a particular direction. So at a point, you will substitute the value of t, the same value of t, into x definition and y definition, and you get Cartesian coordinates of that point. The domain of the parametric equations, the domain of a function that's defined in terms of parametric equations, is simply the range of that first definition, so how the x are defined, and the range of that y equals f of x will be the range of your q of t. So it's simply possible values of y, that means the range of those y equals q of t, and possible values of x, which is the range of p of t, will give you the range and the domain of y equals f of x. So a quick example, here you've got a sketch. This is a function that's defined in terms of t. Y equals t squared plus 1 over t, and y equals to 2t. T is clearly only positive. And as you go along here, you could, for example, substitute t equals 1 into the definitions, and it will stop at this particular point over here on the curve. So let's say if t is equal to 1, x is going to be equal to 1 squared plus 1 over 1. So it's going to be 2, and it's almost 2, and y is going to be equal to 2 times 1, which is 2 as well. Well, that's not what's going on. I must have sketched it. Hold on, let me just check. 1 plus 1 is 1. Yeah, so it's actually going to be 2, 2. Oh, maybe this point over here. That would make more sense. Yeah. I wonder which one is this one. Maybe a half. Let's try a half. So when t is equal to 0.5, x is going to be equal to 0.5 plus 1. So it's 1.5 over 0.5. So that's going to give me 3. So it's somewhere here. And y is going to give me 1. So maybe this one was meant to be 0.5. Anyway, it shows you that as you move along, as your t's increase, you're going to find points along the curve. If you put t equals 2, that will give you 5 over 2, so 2.5. There you go. And then for this one is correct. There you go. So if you know the value of t and you know the definitions of parametric equations, you can find any point on the curve. There you go. So we're going to have a look at some questions. So the first question, example 1, we've got Cartesian parametric equations, x equals 2t and y equals t squared, and we need to find the Cartesian equation, bearing in mind t only goes from -3 up to 3. So Cartesian equation, to find the Cartesian equation means to get rid of t's. So we need to look at those equations and we need to eliminate t. So we find the combined equation, and so y equals a number of x's. Okay, so just to get ready, you've got y equals to t squared. So I'm going to rearrange my x and give me t equals x over 2. And I'll sub it into this, so it's x over 2 squared. That gives me x squared over 4. So y equals to a quarter of x squared is the Cartesian equation. Let's find the domain and range. So the domain, as t's go between -3 and 3, I need to see what is the range of this function. What are the possible values of x's that I will get if I put t's between -3 and 3? So you can actually see that x of -3, that will give me -6, and x of 3, that gives me 2 times 3, which is 6. So since it's a linear function, all the values between -3 and 6 are the domain. So the domain x belongs to a set of real values, and it's between -6 and 6, if you want to write it in the set notation. The range is going to be all possible values of y if your y function is t squared, again between -3 and 3. Now if you put y of -3 and y of 3, you'll get the same answer of 9. So you can't just say the range is 9. You need to realize that it's a quadratic function here. So remember, if I were to sketch a quadratic function, y equals t squared, that will go from -3 up to 9 here, and then over here from 3 up to 9. But you can see it goes all the way down to 0. So you'll have 0 all the way up to 9. And that is the range. So y belongs to real values. Then it's y is between 0, including 0, because the minimum point included between -3 and 3, up to 9. 9 is not included. There you go. So sketch now the quadratic function that we found, y equals a quarter x squared. So we are going to sketch this one from its Cartesian equation between the values of x from -6 and 6. So -6 and 6. So x is equal to -6 or 6. That will give me 36 over 4, which is 9. So that's going to give me actually the same one as this one. Just double check. 36 over 4 is 9. And we're not going to include those points. So that's my sketch of the function that's defined in parametric, in the example 1, parametric equations, x equals 2t and y equals t squared. Let's have a go at example 2, and then we'll be able to have a go at exercise 8a. So in this example, we have a look at the two functions, y equals ln of t plus 3 and y equals 1 over t plus 5, so reciprocal function. First of all, they were asked to find the Cartesian equation, and we need to find the value of k, so the domain, because x is greater than k. So t is always greater than -2 in this particular instance. Okay, so remember with the over here, with ln t plus 3, if you just didn't have any mention of t, you know that there's a restriction of the domain of the natural log function and log function, so you need to be careful here, because the bracket always has to be greater than 0. but they've restricted it even further. So let's see what we can do. Let's look at the Cartesian equation. So y is equal to 1 over t plus 5. So I need to have t. So using the first equation, x is equal to ln of t plus 3. Let's rearrange it. So give it an e to the power of x is equal ln, and e will cancel. You've got t plus 3. So t is equal to e to the power of x minus 3. So we're ready to substitute that into our equation. E to the power of x minus 3 replaces t plus 5. So this is 1 over e to the power of x plus 2. So this is our Cartesian equation. So we're going to have a look at finding the value of k. So the value of k is simply, we need to have a look at t being greater than minus 2. This is the domain. So for the domain, we're going to look at ln of t plus 3. So if you sub t is equal to minus 2, you're going to get ln 1, which is 0. Okay, so that tells me that x is going to be greater than 0. If you're not sure if it's greater or smaller than 0, try another value for t. So we've tried minus 2, and I tried ln of when t is equal to 0, for example. So you put ln and then 0 plus 3. You're going to get a value that is greater than 1. So try t equals 0, because we've tried minus 2. So x is equal to ln of 0 plus 3, and that gives me 1.09. So you can see that from 0 you've gone up to that. Also, you always need to be confident you can sketch that graph. I always like to sketch my ln function. This is ln of t. So we've got t plus 3, so it's shifted. The asymptote is at t is equal to minus 3. And it's just and this one here is minus 2. And you could see that in this particular, because we start from minus 2, we are only dealing with that part, this part of the graph. Let me just do it, color it a little bit more. There you go. So you could see that because this one here is a sketch of x, so this is x is represented as your y-axis here. So you could see that x is going to be greater than 0. So if you compare to that, that gives me k is equal to 0. Okay, now what's the range? Okay, so the range is going to be, you can either look at y equals to t plus 5. Both ln and reciprocal functions need to be, and the quadratic, you need to be very careful with this one. You see, the reciprocal function, as you put the values of t into that reciprocal function and they get bigger and bigger, the value of y will get smaller and smaller. But you can also look at the sketch in a minute. But let's put t equals minus 2. You're going to get y of minus 2. Let's write it properly. So that's going to be 1 of minus 2 plus 5, which is 1/3. So the mistake students make, they just put the range is y is greater than 1/3. But have a look at other values of t before you proceed, and always check it with the reciprocal function. So let's try 0. Y of 0, so you're going to put 1, and then you put ans, no, I'm going to put ans plus 5. Okay, so if it was 0, let me just double check. The answer is going to be 0.2. Okay, now 0.2, you could see this is smaller than 1/3. Let's try even a bigger value of y. Maybe y is equal to 10. Why not? Okay, so if you put 10 equals, Scroll up. Okay, you could have the answer of 0.01, well, it's 0.06 recurring, so 0.1. So you can getting smaller and smaller. Now, no matter what you put as t, because you start putting values of t that are bigger and bigger but positive, y will never go into negative values. So you could see that it will get closer, try to get closer and closer to 0. Let's just try, just for the last one, let's put like 1,000 in. Okay, so if I put 1,000, scroll up. Okay, so this is 9.95 times 10 to the power of minus 4. So this gives me 0.0000995, etc. So that's close to 1,000. Yeah? So you can see that it gets closer and closer to 0. So the range will be y's. It's going to be greater than 0, and then you stop at 1/3, because 1/3 is what you obtained when it was minus 2. So it's going to be 1/3, sorry, 0, not getting to 0, so not equal, and 1/3. Okay, I'm going to actually sketch your reciprocal graph, y equals 1 over t plus 5, because I do believe it's better to, well, it helps you a little bit if you are confident you can sketch those tricky functions like reciprocal functions, like ln functions, like quadratic functions, when in the questions where they ask you to identify domain and ranges. So if you do it every single time, you will become very quick. And also if you've got a graphical calculator, that will help you. So reciprocal graph, it's shifted 5 units to the left because it's t plus 5. So that goes through, the asymptote shifts to t equals minus 5. And then you've got positive branches, because it's just your 1 over t, or 1 over x, if you like, if it was in terms of x. So we've got minus 2 somewhere here. Minus 2, we said when it's minus 2, you got 1/3. And you could see as t goes bigger and bigger and bigger, we are going to travel along this branch only, but trying to get to this asymptote, which is your x-axis, well, your t-axis, a y equals 0 line. So you could see that in effect you're going to obtain the values only between 0 and 1/3. There you go, because you only have that part of the branch. So y is between 0 and 1/3, and this is your graph range for that function. Okay, so this will take you to exercise 8a.